Hey, thank you so much for letting me come and observe your class. So I appreciate you doing this.
Yeah.
So we're going to just do a pre-conference, and I'm just going to ask you a few questions, and then
Okay.
you can ask questions and see how things go. So,
Okay.
so tell me what you're doing today.
So we're kind of kicking off the year with an introduction into the differences between scientific thinking and the scientific method.
Okay.
I've spoken with enough professors and people who actually engage in scientific work, as opposed to just teaching it like I do, to realize that the scientific method is a little outdated. It's very linear, where scientific thinking is a cycle, and it's a process. And so I've kind of adapted that approach to, trying to stay within what the state is asking us to instruct. This approach from getting away from this linear, A to Z kind of approach with the scientific method, and instead implementing this cyclical pattern of scientific thinking.
Awesome.
That involves much of the same steps, but instead of arriving at a conclusion and that being it, it leads to more questions, and it's just a constant cycle. And I love having this conversation with them, kind of giving some real world examples as to how that would look. And then we do a little lab activity where they're given bits and pieces of information, of evidence, and as a group they get to kind of come up with their own explanation of what's happening, develop their own little explanations and tentative theories, you could say, or tentative explanations. And then at some point they get to collaborate with others who are looking at the same bits of information, which is exactly how the science world works. Collaboration is an essential part to discovery, and so it's a fun little lab that they get to engage in scientific thinking, oftentimes without even realizing they're doing it. Because when they hear the term scientific thinking, a lot of them just kind of tune out. But
right.
It's a fun way to get them engaged and understand how it actually works.
So if you were to sum up your objective, what would you say it is?
I want my students to be able to differentiate between the major components in scientific thinking and the scientific method, but that's not to say that the scientific method isn't important, but to understand that the scientific thinking has a root in understanding, that it's a process, and it's a changing, evolving process. That was a long objective, I'm sorry.
No, that's good, because that helps with the thinking. So
here are the three objectives I have throughout this lesson. The student will be able to distinguish the major differences between scientific thinking and scientific process. That's our discussion. The student will be able to identify important qualities and components of scientific thinking, which are inference, evidence-based, tentative/temporary, and collaboration and debate. And then, so that will be, discussing the actual lab itself. And the student will be able to engage in scientific thinking process by completing the checks lab, which is, actually engaging in the process.
Okay.
So we'll discuss those, and then they'll put those into practice.
Excellent. And so you're, with these objectives, how will you know if they got these? What's your assessment of it?
Step one, or the first part of it, as we talk and discuss the differences between scientific method and scientific thinking, I always try to engage the students in conversation. I'm not a huge lecture style type of teacher, and so I like to lead them in a discussion and ask leading questions that cause them to give me, the answers that I'm looking for, hopefully, if it all works out that way. And so that's one way that I'll check for understanding with the first, with our first section, is to make sure if they're asking the right questions, if they're engaged in conversation with me, then I know they're at least in that process of scientific thinking. Introduce them to the checks lab, highlight and explain the important qualities and components. So what I'll do is I'll ask for examples of each of the components. So as we go through them, I want to make sure that the vocab that we're using, that they understand what that means. Yeah.
Okay.
And if they don't, we'll define it, and I'll give examples of what that would look like. So just engaging. The one thing I like to do with each of these is also just simple checks for understanding. I know some teachers use 5, 4, 3, 2, 1. I like to do thumbs up, sideways thumb, or thumbs down. Anyone, if I ever see sideways thumbs or thumbs down, I know I need to maybe go into a little more detail on that.
Okay.
And then when it comes to the actual activity, I just pace the room, and I can tell when students are getting it. There's excitement in the discussions. If I ever see a student who's kind of just off on their own, I I don't tell them to get back in the group, but I ask them a question that gets them involved in the group, or I ask their group a question that, you know, naturally just kind of pulls hopefully everybody in. If they refuse to, I just gently push them over and say, hey, come on over and participate.
Great.
But that's the biggest check for understanding right there, is just making sure that they're engaged and having fun and asking the questions. So.
Okay, so I'm hearing that you're going to do, most of it is going to be oral. So you're
Yes.
going to be listening for how they respond to
Yeah.
your questions, and then also how they're engaging with each other, so you're observing what they're doing.
Correct.
Awesome. Do you anticipate any problems?
With this lab, especially with it being at the beginning of the year, I don't know if that plays a role in, you know, people not, you know, participating. I feel like most people are really engaged at the beginning of the year, and so this lab's always really fun. It's one of my favorites because everyone always seems to be kind of excited. It's still, you know, the beginning of the year, and so everyone's excited to get started. So I don't usually have any issues with students not participating per se. However, I have had issues in the past where they just miss the mark in understanding what it is we're trying to do with the collaborative bit. Instead of them collaborating with other groups to kind of piece together, because when they pull out, each of them are going to receive an envelope, and within the envelope, we call it the checks lab because it's kind of like a mystery story about a family.
Okay.
But just like in the real world, you're never privy to all of the information out there.
Mm-hmm.
And so each group is going to be pulling out at random different checks. And so they're going to be getting different checks, which means they're going to be coming up with different explanations. And at one point, I'm going to have them explain to another group who has different checks what their explanation of the story is. And most of the time, the students get it like, oh, okay, you've got information that I don't have. Let's piece together our stories and see what we could come up with. Other times, students don't quite grasp that concept.
But that's the point
yeah,
of
they
it,
don't
is for
get
them
that.
to get together.
Yeah, and see how their story changes.
Mm-hmm.
And rather than adjusting their story based on what others are saying, they kind of just smash them together, and there's no cohesiveness between the two.
Gotcha.
So I kind of have to explain how, you know, when scientists work, they're never alone. They're not the only one likely working on this whatever it is they're working on. And when they share their information and their findings, that opens up new doors that they didn't even know existed. And anyway, so that's kind of the fun part about it as well, is kind of highlighting that aspect of
That
science.
sounds like a great activity to really get them into doing the thinking that you're
Yeah.
asking them to do without really telling them that that's
Yeah.
what you're doing.
Yeah, that's fun.
Awesome. Okay, so as I come in here, what can I do to be a second set of eyes in your classroom to observe something? What's your goal?
My goal in this one, and like I said, it's a pretty good one just because it's the beginning. It's a good lab as far as getting people involved. I just want the students to have fun, to be engaged, to be hands-on, and to participate with their groups. So I like to do 8 groups. That way the groups aren't too large.
Okay.
So eight tables, and they are all working on their own tentative explanations. The lab worksheet, I guess I shouldn't say it's all oral. They do have a guided worksheet that asks them to, you know, list their first explanation, and then they'll get some more checks. They'll get to pull out a couple more checks, and then they have to add that to their timeline, and then that will change their explanation. So then they'll write that down, and then they'll do it again, and then their final explanation will be after they've collaborated.
Okay.
So what I'm mainly looking for as I walk around is I want to see that their explanations are changing
And
with
they're
the new
progressing.
information. Yeah, they're
Okay.
progressing towards
Okay.
something that maybe makes a little bit more sense, while at the same time having fun with it. Some of the stories they come up with are hilarious, and
Great.
so
I bet.
as I walk around, that's really what I'm looking for, is that they're engaged, that they're having fun, and that they're actually applying what it is we're talking about, that as new evidence comes into light, they're changing their explanations and their theories, even though they aren't, you know, concrete yet. And then we go through and we answer these discussion questions together. So, you know, as you're walking around, mainly just seeing who's engaged,
Okay.
maybe making sure that, you know, I tend to wear a spot right here.
Okay.
So maybe
you know your
proximity,
pattern.
my proximity, making sure I'm, you know, not just engaging these 2 front tables, but walking around and, you know, participating with all the groups.
And what I'm hearing, what you mean by engagement is that they are actually collaborating with each other.
Correct.
And
Yeah.
meaningfully having these
Yeah,
conversations.
that it's not
Right.
one person stealing the show at a table, but rather everyone's giving input, giving their
Uh-huh.
explanations, and then coming together to create just one answer. Because they should all have the same. They have to come to some agreement on what the explanation should look like. There shouldn't be 5 different explanations at one group.
So if I just map out your classroom and have each student with their own little separate box, and I do a code like collaboration being one of them, or just sitting there would be another code, or if they are, and then what they're talking about, and maybe scripting some of
Yeah.
their conversation, would that be
That'd be
meaningful
great.
for you?
Yeah, it'd be awesome to know, which groups had, great participation, because these groups that they're in, they're going to be in these groups for other activities as well, like throughout the term.
Okay,
So that would be very helpful.
then
to-
you know who's
to
working
receive.
with each other and who's
Maybe
not.
keep an eye on, let's
Yeah.
see if we could get these guys engaged, or even
Awesome.
approach some of them, in private, the ones who are super engaged, and say, hey, so-and-so, our last activity wasn't really participating, let's see if we could get him or her involved this time, so
Okay,
that'd be
awesome.
awesome.
This sounds like a fabulous lesson. I'm
It's
really
fun.
excited to come and observe it.
Cool.
Appreciate it.
Yeah, thank you.
Okay, thank you so much. We'll
Yeah.
see you soon.
All right, thanks.
Bye.
Oh, sorry.